Okay, so algebraic equations, right? When we do algebraic equations, we solve for x. Okay, but now we get equations in trigonometry now as well. Okay, but now instead of solving for x, y, and z, we're going to have to solve for? We're going to solve for theta, because remember, theta is your unknown in trig. Okay, this is your unknown, is this. This theta is your unknown. Okay, and quickly tell me, theta is an angle. Okay, so this theta is an angle. Okay, and I'm going to teach you, when we're solving for an angle, we're going to have to do something a little bit different to what we've done before. Okay, so I'll systematically work through it with you. Okay, so normally what your first step would be in equations with trigonometry is you'd have to isolate your ratio. So you're going to have to isolate sin, cos, or tan. In the first example, it is already isolated. Can you see? You only have cos theta on the left-hand side. Okay. Now the problem is, with normal equations, what we do is we have to always start doing the inverse operation to solve for x or for y, whatever the case is. So if you're adding with 2, you take it over, you're going to subtract 2. If you divide by 2 on the left, you're going to multiply by 2 on both sides. Okay, does that make sense? Okay, so the whole point over here is to solve for theta. What is the problem to having theta on its own here? What's in the way? Cos. Okay, you can't just go and divide by cos. Okay, remember, inverse operation, dividing by cos is not the inverse of what's happening over here. Okay, the inverse operation is going to be cos with a little 1 on top there. That is the inverse to solve for theta.
Oh, because the exponent is positive when it's the sign.
Okay, so what's going to happen is you're going to take cos theta. Then to get rid of cos theta on the left-hand side, you are going to second function. Okay, second function is that. Shift cos to get that on your calculator. I'm going to show you now. Okay, so we're going to cos -1. Okay, so cos -1 on your calculator. Cos, shift cos. Can you see? So if you look over there, there's your second function over there, on top of cos. There, can you see it? Okay, that's why we shift cos. Right? But now do you see there's a bracket? Okay, what's obviously going to go in the bracket? 0, 3. So by use second function shifting cos, you're getting rid of cos here on the left. On the left-hand side, you only have theta. And what is the value of theta? 72.54. Okay. Yeah.
Shift cos when
Yeah.
shift is
Okay, the next one. We always want to make sure that our ratio is isolated on either the left or the right hand side, which it is. We've just got tan theta on the left. Okay, the next step would be to obviously get rid of tan, so we have only theta here. Okay, so we want to get rid of tan. And the only way to get rid of tan is by shifting. The inverse function of tan is tan -1. Okay, so we're going to have tan theta. It's just an extra step I'm showing you here. You don't need to write it in the test. You're going to have tan, second function, and in brackets you're going to have a 5. Now this tan second function, inverse function, gets rid of tan here on the left. Okay, and we're only left with tan now on the left. I mean theta on the left. Are you guys fine? Okay, in your calculators, you're going to put in shift, tan, 5, and your answer is 78.69. You guys understand that? Two decimal places. The third one's a 0, so it stays just like it is. Okay. Degrees. Okay, so let me ask you a question. What conclusion can you make when you're calculating an angle? No, just in general, in trig, when you're calculating an angle. To calculate an angle, you're always going to second function. You're going to shift. Okay, inverse function. To calculate an angle, we're going to shift tan, cos or sin. Okay, does that make sense? Right, next. First question you ask yourself, if you're solving for theta, is our ratio isolated on the left-hand side? Yes. So we don't have sin theta plus 1. Because then it wouldn't be isolated. We'd first have to take that plus 1 over. Does that make sense? Okay, but in the next example, we've got one like that. Okay, so what we're going to do over here is we're going to second function sin. So on the left, again, you don't need to show this step. We're going to have sin minus 1. Yeah. Okay, that second function, that shift, gets rid of sin on the left. You now only have sin on the theta on the left-hand side. In your calculators, you'll go push shift, sin, 0.0696. Close your brackets, push equals, and theta is going to be equals to 3,99 degrees. So all this is telling you, this is kind of telling you that there's a restriction. So in all of these examples, theta is going to lie within 0 to 90 degrees, which is here. Do you see? 0 to 90. So how much is theta? 72.54. Does it lie within my restriction?
Yes.
78.69. Does it lie within my restriction? And 3.99. Does it lie within my restriction? Okay, do you understand? So that's just telling you that we are working in the first quadrant.
So we both like that.
Yes. Okay, we're working in the first quadrant. Okay. Move on. Okay, next one. First question you always ask yourself, is your ratio isolated? And is it alone on the left-hand side in the next example? No, it's not. Why? Because we've got a negative 0.5 along with the sin theta. Okay, so your first step over here is to isolate the ratio. And how do you do that? Taking that over and it becomes a plus 0.5. So what do I have left on the left-hand side now after we've taken it over? Okay, we've got sin theta. And what do I have on the right-hand side? Okay, 0.5. Okay, my ratio is now isolated. How do I now get theta alone? Okay, shift sin. Okay, so we're going to have sin theta is equals to sin, second function, 0.5. Now again, if you guys leave that out, it's fine. Okay, so theta is going to be equals to shift sin 0.5, 30 degrees. Okay, does that make sense? Right, next one. Do we have tan alone? Okay, so how do I get tan theta alone on the left? Yes, I heard it. You divide. There's not a 106 plus tan theta. It's right next to, so you just divide.